So now we're going to work through some questions like you would see in an exam before you go on to work on some of your own. So the first thing we have here is a triangle. It is a right angle triangle because we have a right angle here. So the triangle, it says, is drawn accurately. Now, drawn accurately means that you need to measure it. You need to take a ruler and measure this. Now, that's a little bit hard in a PowerPoint because people's screens are different sizes. So measured on paper, this triangle comes out as 3.8 centimeters height and 5.6 centimeters along the base. So to work out the area, we have base multiplied by height and then divide it by 2. So we have 3.8 multiplied by 5.6. We're going to times them together, which gives us 21.28. And then we're going to divide it by 2, which gives us 10.64 centimeters, because we're measuring in centimeters, squared, because it's area. So the next question, question 2, we've got a triangle, and this time we've been given algebraic expressions for the lengths of each side. So question A wants us to calculate the perimeter of the triangle if x is equal to 3. So again, perimeter is the measurement around the outside. So these 3 sides added together. So we're going to start out by writing out the formula as an addition. So we have our 2x plus 3x plus x plus 9, because we've taken them from each side. So we've got that. That looks a bit confusing. So we're going to collect our like terms. 2x plus 3x, that's going to give us 5x, plus another x is 6x, and 9 is our only number. So it is 6x plus 9. So now we have that. We can now substitute in our 3. X is equal to 3. So it becomes 6 multiplied by 3 plus 9 equals 27. Because our 6 multiplied by 3 is going to give us 18. Add 9 is 27. Part B to this question is asking if the perimeter is 48 centimeters, we need to find x. So again, let's write out our formula. 2x plus 3x plus x plus 9 equals 48. These 3 sides added together are 48. Collect our like terms. Again, we get 6x plus 9 because our 2x, 3x is 5x, another x is 6x. So that's our 6x plus 9 equals 48. So now we just need to break this down. So we want to find x, so we're going to get rid of the positive 9 on this side, which means we also need to get rid of positive 9 on this side. We get rid of the positive 9, we're left with 6x on this side and 39 on this side. So we need to find 1x. So we're going to divide this side by 6, but because we divide this side by 6, we have to divide this side by 6 as well, which gives us x equals 6.5. Question 3, we've got a diagram of a field. Now we've been given some measurements along here. We've got 280 meters along here, 198 meters along here, and 86 meters up here. Now, this type of shape is a trapezium, as we looked at earlier. So we've got 2 parallel lines going along here, and we know that because we have right angles here. Because they're both right angles, these are both parallel lines. So let's remind ourselves of the formula for working out the area of a trapezium. The area is half of a plus b multiplied by the height. So let's put our a's and b's in. A and b are here because they are our parallel lines, and our height is 86 meters. So the area of the field is going to be half of 280 plus 198 multiplied by 86. 280 at 198 is 478. Multiply that by the 86, and half it gives us 20,400 554 meters squared. Meters squared because we're measuring in meters, and it is the squares inside this trapezium. So that's part A. Now let's look at part B. 1 acre equals 4,047 square meters. A farmer keeps cows in this field. He is allowed 7 cows per acre. Work out the maximum number of cows he is allowed to put in the field. We know that the meters squared here, the area of the field is 20,554 meters squared, and we're going to divide that by 4,047, which is going to give us how many acres are in here, which is 5.079 acres. Then we're allowed 7 cows per acre, so we've got 5.079, which is our acres, multiplied by 7. How many cows we can have in this acre gives us 35.5 cows. Now obviously we can't have 0.5 of a cow, so we are left with just 35 cows, because I'm pretty sure a farmer doesn't want half a cow in his field. Question 4. So this diagram shows a trapezium. It says it's not drawn accurately, and we've been given some measurements. We've got x centimeters along here, 5x centimeters along here, 3x centimeters along here, and 5x centimeters down here. Part A to this question, they want you to write down the length of AB when x equals 6.2. So you'll see all the corners of this shape are labelled. We've got A, B, C, and D. When it's asking us to write down the length of AB, it's asking us to write down the measurement from A to B. A to B is 5x centimeters, and it's saying that x is equal to 6.2. So 6.2 multiplied by 5 is 31. And that is the length of this side when x is equal to 6.2. The next question is asking us to write down an expression for the perimeter of the trapezium. So the perimeter, remember, is the length all the way around. All 4 sides added up. Let's look at this question. So let's write down our addition first. We've got x centimeters at the top, so that goes there. X centimeters plus 5x down here, plus another 5x, that's the measurement along here, and 3x is the measurement along here. We're going to add them together. So now we've got this, we can collect the like terms to make this a bit simpler. And we have been left with 14x. So x plus 5x, that's 6x, plus another x, plus another 5x is 11x, and then add 3x is 14x. That is an expression for the perimeter of the trapezium, 14x. Question 5. We've been given a hexagon. It's made from a rectangle and 2 congruent triangles. Now, congruent just means that they are exactly the same. They've just been either flipped or moved or rotated. So here, it wants us to work out the area of the hexagon. Now, up here, we've been given a measurement of 21 centimeters. We've been given a measurement of 18 centimeters along here and 13 centimeters here. Now, this 21 centimeters is the measurement from here to here, the perpendicular height of the whole shape. So we want to work out the area of the hexagon. The first thing we're going to do is work out the height of each shape. So the height of this rectangle here is 13 centimeters because we've been given that measurement here. However, we haven't been given the measurement of this triangle or this triangle. But if the whole thing is 21 centimeters, we are going to subtract the 13 centimeters from here. So take away 13 centimeters leaves us with 8 centimeters. So there are 8 centimeters left. Now, because these triangles are congruent, they are going to be equal. So we need to divide that 8 by 2, which is going to leave us with 4. 4 centimeters up here and 4 centimeters down here. We're going to work out the area of one triangle first. So we know that this measurement along here is 18 centimeters, and the measurement height is 4 centimeters. So we are going to multiply them together. 18 multiplied by 4, and then divide it by 2 is going to give us 36 centimeters squared. That is the area of one triangle, which means that the area of the other triangle has to be 36 centimeters squared too, because they are congruent, they are the same. So now we've worked out the measurement of the areas of these two triangles, we need to work out the area of this rectangle in the middle. We know that this measurement down here is 18 centimeters, and this measurement up here is 13 centimeters. So we're going to multiply them together. 13 multiplied by 18 is going to give us 234 centimeters squared. And that is the area of the rectangle. So now that we have the area of all three shapes, we need to work out the area of the hexagon. So we need to add together these three areas. 36 add 36 add 234. And that gives us 306. And that is the total area, and that will be 306 centimeters squared is the area of that hexagon. So when you see questions like this, you want to see if you can divide the shapes up. If you get a hexagon, can you divide it up into other shapes? Question 5. We've got an L shape here, and it has an area of 12 centimeters squared. All the corners are right angles, and all the lengths are in centimeters. So we need to work out the value of x. So we know that the area around here is 12 centimeters squared. There are 12 square centimeters inside this shape. We've been given a few measurements. Down the bottom, we've been given x plus 2. Up here, we've been given a measurement of 3. Now it's 3 centimeters because in the question it says all lengths are in centimeters. So up here we've got 3 centimeters. Up here we've been given a measurement of x centimeters and 1 centimeter. We have not been given a measurement for this length or for this length. So the first thing we're going to do is break this up into two shapes. We have a rectangle here and a rectangle here. So this first shape here, we need to work out the area of this shape, which is 1 multiplied by x is going to give us x. And the area of this shape down here, 3 multiplied by x plus 2, that's going to be our area for this shape. So 3x plus 6. So now we can collect those all together. So x plus 3x plus 6 is 12. So we're going to collect our like terms. We've got x and 3x, so we're going to put them together to make 4x. Our 6 is by itself, so we're just going to leave it there. 4x plus 6 equals 12. So now we want to get rid of, because we just want x on this side, we're going to get rid of this positive 6. But because we're getting rid of positive 6 here, we need to get rid of positive 6 on this side as well, which leaves us with 4x equals 6. We're going to divide this side by 4 to be left with just x, which means we need to divide this side by 4, which leaves us with x equals 1.5. Now you've had a go at those, you can have a look at the practice paper. Feel free to come back to these videos, watch them again, make some notes. If you've got a question, come back to this video and see if you can find a similar question to it. There's lots to take in here, so do try and watch these a few times and use the information in these videos to help you solve the questions that you've got on the worksheet.